Hello students, welcome back. In this video we're going to dive right into our territory capture game, Territory Rush. Here we're going to focus on two main things for our game. The first being our gameplay world. What do we want the world that our player moves through to look like? And what feelings do we want our user who's playing the game to feel as they play Territory Rush? So we'll address color schemes and sizing of various objects that fit within this world to suit those exact goals. Then we'll focus on our player. This is the thing our user is going to control inside of our game world. How are we going to move through our world and interact with various objects that we find? So let's head to the computer screen and we'll dive right into lesson number 1. So I have a web browser open here because I am going to use a web-based IDE, vscode.dev. So everything that I code is going to be done right here in the browser. If you have a dedicated IDE installed on your computer, you absolutely 100% can use this. But I'm going to use vscode.dev to show you that there is no need to install any extra software here. We can run everything directly in our browser. So if you go to vscode.dev and hit enter, we'll open up Visual Studio Code's web-based IDE, and I'm going to click Open Folder. So open, and we're going to go to my desktop, which is where I have my Territory Rush folder, and I'm going to select that folder to open it in VS Code. I'll select Allow, and then yes, you can trust the authors of these files. The authors are myself. You can trust me. And when I do that, it opens up 8 different lessons. So right here are the 8 lessons that we are going to work through together to build Territory Rush. Now, in each lesson, you have 2 different files. You have lesson final and lesson starter. Your starter file is where we are going to begin. We are going to work out of these starter files and code together. But I've given you the final version of code for every single lesson. This is here for you to reference. If you get stuck on, say, line 140, you can come to the final version of the code and look at line 140. Compare it. See if you can debug your own errors and fix the code. You could also simply copy the code and paste it back into your starter file. So this is like it's like a safety net there for you in case you need it. But I am going to open up lesson 1's starter file because we're going to want to code these lines together. So not only do we have this starter file where we're going to write all of our code, but I'm going to minimize my web browser and head to that Territory Rush folder. And I am going to open lesson 1 and I'm going to open the starter file directly because this is going to open up the current state of my game directly in the browser. So I have the code for the current state of the game and the current state itself. And if we look, it's a pretty bad state. I mean, this looks pretty bad. I'm hitting my arrow keys. Nothing's happening. I'm non-responsive. So I think this is probably my little player. The color schemes are bad. I can't move. I got game name up here in the HUD. So we got a lot of stuff that we have to fix. Now, before we get into fixing anything, I want to overview what is in this file. This is an HTML file, or Hypertext Markup Language file. Hypertext Markup Language is basically the language of the internet. All of our content that's out there on the internet exists in some form of HTML. HTML is basically composed or built out of these things called tags. So if you look here, I have a title tag. This is the opening tag. And here is the closing tag. So the vast majority of tags you open and you close. And then you put content inside of the opening and closing tags. So inside of our title tag, my game is called Territory Rush. And if you notice here, right up here in the tab, it says Territory Rush, right up here in the title of the game. If I change the content, I'm going to change it to my first name, Mike. And I click Save and refresh the page, the content up here changes as well. So we're going to change that back because a title for this game of Mike is just terrible. We don't want that at all. So now that we understand that tags are just a way for us to put information, let's go look at some of the other tags we have. We've got something called a script tag right here. And if you notice, we've got a big opening script tag and then a closing script tag. And it's weird because this is our closing script tag. This is our opening script tag. There's nothing in between here. There's nothing here. So what is the point of this tag? Well, a script tag is for the JavaScript programming language. This is where you would write code. And we're going to use the JavaScript programming language to code our web-based video games. We're going to use it to code Territory Rush. Now, there is no code here. So what's going on? Well, this script tag is doing something really important. If we look here, we are bringing in an external library of JavaScript code. Think of this as a bunch of code that's already been written that we now have access to because we brought it into our game. And this library of code that we are bringing in is called the P5 library. The P5 library is really, really, really great at giving us functions or tools that we need to render things to our web browser or draw things to our web browser. So let's look at the state of our game. We're rendering or drawing our player. We're rendering or drawing this background with these lines. We're rendering or drawing this HUD or heads-up display and the text that is inside of it. All of those renderings help or are helped by this library, the P5 library. So we're going to talk a lot about that library and how we can use it to make our JavaScript games. So let's go a little bit further. What other tags we got? We got style tags. Okay, there's an opening and closing. Ooh, I have another script tag. Now, what's inside of here? Well, this is my opening script tag. Let's see if we can see where it ends. Where do I close it? So all the way, we're still going. Whoo, all the way down here at line 240. So in between that opening and that closing script tag lives all of our JavaScript code. This is code that we are going to work with. This represents the current state of our game. So let's see what is right up at the top of this script tag. Well, we have our game title and lesson title, lesson 1, the world and player. And then we get something called a mission checklist. Every lesson that we do, we are going to have 8 missions, 8 small little sections of code that we are going to try to fix or adjust or write ourselves. And in doing so, solving each individual mission one at a time, we are going to take our terrible, terrible state of our game. This is the terrible, terrible state of the game, in case you forgot. And we're going to turn it into a much better version, something that is playable, something that is more fun and more engaging. Now, before we get into solving these missions, let's go see what else is in our code. Next, we have something called the student edit zone. It says right here, it is safe to modify anything within the student edit zone. Think of things that are inside of the student edit zone like knobs or dials that we can turn and adjust to change these numbers. And turning and adjusting the knob or dial on a given system or variables changes how that system plays or looks or feels in the game. If you look here, mission number 6, we want to adjust the player's speed. So we could turn this dial up, 7, 8, or 9, or turn it down, 5, 4, 3, 2. For right now, we're going to leave it at 6, and we'll come back to it. We also have colors in our student edit zone that we can change. Anything inside of the student edit zone will not break your game if you change it. It should not break your game. This is like your ability, this is like your space to explore and experiment. But no, there's an end to that. So there is an end of the student edit zone. Once you go outside the student edit zone, any changes that you make out here could break your game if you make them incorrectly. Now, we're going to have to make a lot of changes out here, and you're going to follow along because we're going to code all of these lines together. But if you get stuck, you have the final version of your code that you can always reference. So there is your safety net. Now, let's see what is outside of the student edit zone. Well, we've got gameplay variables. All right, so we've got some variables here for gameplay, it looks like, and we'll discuss those. Then we have some functions, and a function is a really great tool. It's like a way to write a set of instructions that we can just follow anytime we want. So if you look here inside of this function, the setup function, I have 3 lines of code, 3 instructions. Instead of giving those 3 instructions over and over and over and over again, let's say I wanted to do this 4 times, well, 4 times 3, that's 12 instructions, 12 lines of code I'd have to write. I can just call the setup function 4 times, and it will run all of those instructions for me. Now, the setup function and the draw function are super, super special. They are P5 game loop functions, and the P5 library will explicitly call this function and this function for us. It will run the instructions that we put in there. The setup function will get run once automatically at the start of our game. So if I refresh my page, that setup function just got run. And if I refresh it again, that setup function just got run right at the start of our game. The draw function, on the other hand, will run every single frame of our game. So every single frame, if I'm running at 60 frames per second, this is going to run these instructions 60 times in 1 second. And it looks like I'm calling two other functions. I'm updating my player and I'm drawing my scene. So setup runs once at the start of our game. It looks like we are creating a canvas that has a width and a height. We are setting our text font, so what we want our text to look like. And then we're calling a function reset game to defaults. Maybe, I'm starting a new game, so I want to make sure everything is back to the way it should be at the beginning of the game. And then in draw, what we're running every single frame of the game, I'm updating my player and I'm drawing my scene, it looks like. We're calling two other functions. So here's reset game to defaults. Here's reset player. Here's update player. We got some missions in there. Get input direction. So these are all functions that we have to work with. And then we have drawing functions. Draw scene, which calls draw background, draw player, and draw HUD. So it looks like we have three different layers in our game development sort of process here. The first layer is defining data. So here inside of the student edit zone, we define a bunch of data. We define player speed. We define cell size and player size. We define HUD height and colors and game font. We are defining that data. Then later on, it looks like we update that data. We reset our game to its default values. We update our player. We get our input direction. That's all about updating data. And then finally, at the end, we've updated the data. We changed our data. So we draw that new changed data to the screen. So our three layers in our game development process: define data, update data, and draw data. And we're going to build that out over and over and over again. Okay, so with that understanding here, let's go back to our mission checklist and let's dive right into fixing Territory Rush. So right over here, I get this nice little sort of like window where I can see all of my code. If I just click, and I'm going to click right here in this top region, boop, it brings me right to that section of code. And so here is my mission checklist. Mission number 1, we are about to solve it together, says, let's change the background color of the board. Because we don't want this like pinkish purple looking color here as our background. It doesn't scream Territory Rush to me. So we got to change it. Now, how do we know where to go in our code to find where we will look for mission 1? Well, mission 1 is what I would call a tag. It only appears twice in the entire code. It appears once in the mission checklist, and then it appears another time down below in our code somewhere. To find that second version, hit Control F or Command F on your keyboard. So if you hold the control button down and then hit F, it will pop this right open. And you can search for our tag, mission 1. So if we search for mission 1, you can see I have one of two instances of mission 1. Here it is in the mission checklist, and if I hit the up arrow, I go to the previous, down arrow to go to the next. If I hit the down arrow, it takes me right to where my code is for mission 1. Background color. Change the background color of the board and observe how it changes the mood of the world. All right, well, let's think before we get into this. Should changing the background color break our game? Absolutely not. It should not. And so this finds us inside of the student edit zone. The student edit zone is where we can go to just tweak values. These are like little knobs or dials that we can turn to adjust how something fits or plays or looks in our game. And we are going to tune a knob right now. We are going to tune a knob for the background color. So here is the line that we are going to target. Now, that line has got 4 really important things that we have to understand. The first is that it has a variable name. Our variable name is BG color. BG for background. Now, if you notice, that variable name is all capital letters. When you see that, that is an important realization that what you have is being defined as a constant variable. In JavaScript, when we create a variable, we have to initialize it. And one way we can do that is by typing the word const for constant. That means once we define the variable, over the lifetime of the variable, its value will never change. Once I define my background color in my game for one play of my game, I'm never going to change its background color. So we can make it a constant. Now, a single equal sign here assigns a value to the variable background color. And the value that we are assigning is right here. It's inside double quotes. Anything that is inside double quotes is known as a string. It's an important data type. Now, we're going to see strings a lot. Our string starts with a hashtag, and that tells us that it's a special string. It's something called a hex string. And hex strings, or hexadecimal strings, are one of many ways that we can represent color. Now, this works with the hexadecimal number system. So we got to learn a little bit about hexadecimal. Before we do that, let's just go talk about numbers we do know. You guys, I'd like you to count the first 10 digits. Everybody do it right now. Count the first 10 digits. Okay, I'm going to write out my first 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. Now, many of you out there might have said, oh, the first 10 digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is not a digit. 10 is made up of the digits 1 and 0 together. We have 10 digits, but they are the numbers 0 through 9. And when we run out of digits, we go back to the beginning. And we shift over 1, and then we start over. So 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, on and on and on. In fact, I'm going to go on and on and on. I could just keep counting, but I'm going to stop at 255. We can do that. Let's stop at 255, and we'll talk about why here in a moment. Now, hexadecimal is no different. Hexadecimal, we just count, except we don't have just 10 digits to work with. We have 16 digits to work with. So we start counting. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, what's the next digit? Is A, then B, then C, then D, then E, then F. Ooh, so there are my 16 digits. So now, how do I continue on? Well, I've ran out of digits, so what we're going to do is we're going to go back to the beginning. I've already used 0, so I'll shift over, and I'll start at 1. 1, 0, 1, 1. So hexadecimal, the number F corresponds to 15. In hexadecimal, the number A corresponds to 10. In hexadecimal, the number 10 corresponds to 16. And this could go on and on and on forever and ever and ever until we get to 255. And in hexadecimal, 255 is FF. Now, those are very important ranges because, F font face, where'd that font face come from? There you go, FF. Now, those are very important ranges because in this hexadecimal string, which represents color, we actually have 3 colors mixed together. We have red, which is represented as the first 2 hexadecimal numbers, so 8, 8. We have green, which is the next 2 hexadecimal numbers, 2, 3. And we have blue, which is the last 2 hexadecimal numbers, A3. If we want to change the color, we just need to target the red, the green, or the blue hexadecimal values here for that color channel. Because if you mix red, green, and blue light in any proportion, you can make any color of the rainbow. So let's give this a shot. We're going to take a look. And our range here is anything from 0, 0, meaning give me none of that color, all the way to FF, which means give me all of that color. So let's start by setting our background color to give me all of the red. So FF in the red channel. And I want none of the green and none of the blue. Let's try that. So all of the red, none of the green, none of the blue. This should be a bright red background. Let's refresh the page. And there it is. That really hurts my eyes. That's a little bit too much. So let's add all the red and let's add all the green. So now I have all of the red and all the green with none of the blue. Red and green light make yellow. That does not look good. That's pretty ugly. That's way too bright of a color. So if I want to dull the color, I just need to lower the amount of red. I'll make it 8, 8, and I'll lower the amount of green, 8, 8. So we're lowering the intensity of each color. I still get yellow. It's just not as bright, which looks really good. What if I made every channel the full amount? So give me all the red, all the green, and all the blue. So when you do that, you get white. So white is the presence of all colors. Well, let's go to the opposite then. What if I said give me none of the red, none of the green, and none of the blue? What color would that make? It's going to make black. And I sort of like black. I like that darkness color, but I want a little bit of color. So let's up the red channel from 0, 0 to 0B. And let's up the green channel to 1, 0. And let's up the blue channel to 1, 8. So we have the most blue here. Let's take a look and see what we get. Ooh, I think that looks really good. That's like a slate gray or like a dark bluish gray. I am very, very happy with that color. Now, let's just talk really quickly about the next color that you see here, grid line color. If you notice, this color is not a hexadecimal string. This color is something called an RGBA string. It's just another way to define color. And typically, I define color like this anytime I want something that is a transparent color. So red, green, and blue. We have 3 numbers to represent the amount of red, the amount of green, and the amount of blue in that color. But instead of using hexadecimal, which was 00 to FF, this uses regular old decimal numbers. So we go from 0, which means give me none of that color, to 255, give me all of that color. But there's this special magic number right here, which is known as the alpha channel, or the transparency. That, in this form, is a number from 0 to 1. If it's 0, it means the color will be fully transparent, meaning you will see 100% behind it. So right there, the color is fully transparent. If I make it 1, it will mean that the color is not transparent at all. You won't see behind it at all. And if I pick any number in between, you will begin to fade that color. You'll make it more and more and more transparent. So you can see that that's a little bit more transparent. If I make it 0.5, it's even more transparent. And if I put it back to what I have it at, 0.2, it's even more so that it is transparent. So we're going to see that transparency come up again and again and again. So anytime I need a plain color, I use hexadecimal strings. Anytime I need transparency, I use RGB alpha strings. Mission 1 in the books, we have effectively changed the background and learned a lot about colors. So let's go to mission number 2. All we got to do is just come up here and search for mission number 2. If that was closed on you, you just hit Control F to pop it back open and hit mission 2. Type it in and then find mission 2. There it is in our checklist. And if I hit down, here it is in our code. It finds us inside of a function called the reset player. Now, if you look right above, reset player is getting called inside of a function reset game to defaults, where we do quite a bit. We set some variable called step interval frames, and then we call reset player. It says position the player in the center of the grid. Use grid cols and grid rows to find the middle cell. All right, so I think what we need to do here is we want to put our player not up here. We kind of want to put him like in the center of our board. Well, in order to do that, I think we got to go figure out what variables we got working with. So if you notice, I'm going to scroll up. In our gameplay variables, we have this variable called player. And note that we're not starting it, we're not declaring it with const. It's not all uppercase. This is because we are going to change the value of player as the game goes on. We're going to move it around the board. Its position is going to change. And so when you have a variable whose value needs to change, you initialize it with the word let. Now, our player is known as an object. Anything that is inside these curly brackets is an object. And objects have properties. Our player has a column property, a row property, a dx property, and a dy property. And those all have values. Right now their values are 0, 0, 0, and 0. So that's not really what we necessarily want, because what column do I want my player to sit in? What row do I want my player to sit in? Well, I want my player to sit in like maybe this column here, I don't know what number that is, and what row? This row here, so they'd be positioned right about here. Now you might say, well, okay, why are they not at 0, 0? Well, let's just go check. When we reset our player, when we call this, we change the player's column property. So we do player.column, and we made it 7. Player.row, we made it 3. Let's change those to 1 and 1. Let's see what happens. So if I change it to 1 and 1, 1 and 1, he's like sort of starting there, and then he's like popping over. Why is he moving? I don't know why that's happening. Well, something must be moving him. We're starting him correctly, and then he's moving over. So what we want to do is we want to figure out how do we get them in the center of the grid? Well, it tells us here, use grid cols and grid rows. So I find it interesting that those are all capitalized. That makes me think that they are constant variables, something inside of the student edit zone. So you can stay here. I'm going to jump to the student edit zone. And if we look, we have gameplay constants. We have the number of columns and the number of rows set right here. Grid cols is 40, grid rows is 28. So if you count these rows, there's going to be 28. You count these columns, there's going to be 40 of them. Let's use those exact numbers in mission number 2. So mission number 2, if we want to position that player in the middle, I'm going to do grid cols. the number of columns, and I'm going to divide it by 2. Perfect. And we're going to do something similar for our row. We're going to do, hey, let's do grid rows divided by 2. Except there is only one small problem. When you do this division, it is going to give you a decimal back. We want to chop off that decimal. It's going to give you, even if it was like 40, what was it, 40? I think this was 40. So 40 divided by 2 is going to be 20. It's going to make it 20.0. And we don't want that decimal. So we're going to chop that decimal off. And the way you chop the decimal part off is by calling the floor function. So we're going to say floor, and we are going to put that value inside of the floor function. We're going to do it there, and we're going to do it here. So we're going to do it to both of these. So I chop off that decimal. All right, so I think that is going to work nicely. So if we test this and we refresh our page, we are starting like smack dab in the center. It looks like we're starting in the center. For some reason, we're getting shifted over. So we got to keep looking. Let's go to mission number 3. We're resetting our player to the center, but we got to figure out why is it shifting. So number 3 says, before we do that, let's change the player's color, because right now they're a little ugly. So we got this brings us to our student edit zone. Yeah, we should be able to change the player's color without breaking the game. So let's go look. What do we got? Well, we've got the player's body color, which is this like red right now. And then that is their core. So they're like center color. Let's change each of these colors. So I'm going to pick a body color of F4, F7, FF. Basically, give me almost all of the red, all the green, and all the blue. This is going to be like a nice white color. Hey, there it is, that nice white color. I like the look of that. And then for my core color, let's set it to FFAA 5A. So give me all of the red, a good amount of green, and then a little bit of blue. So let's see, what's that going to give me? Ooh, that gives me like a nice like orangish color, okay? So I'm very happy. It looks like a little fried egg. Hungry. I want to eat that. All right, let's go. Mission 3, done. Our player's visual identity has been changed. So mission 4 is about creating input connection. So it looks here, it says, this says, add vertical movement using the same pattern. Support WS or up and down keys. Okay, let's take a look. So let's look at what's happening in this function, get input direction. We're declaring 2 variables, dx and dy, and we set them both equal to 0. And we use let because we're going to change them. We then ask a series of questions using something known as an if statement. If, and whatever we put inside of these parentheses is the question. So we're asking if a particular key is pressed down. So key is down as a function that is going to check to see if something is being held down. And it's checking to see if key 65 is held down. Now, every key on your keyboard has what is known as a key code. And the key code of 65 is for the letter A. So if the A key is down, and these 2 vertical bars mean or. So if the A key is down or the left arrow key is down, that means we want to move to the left. And so if this question, the answer to that question is yes or evaluates to true, this line of code will get run. And so we take our dx value, which was 0, and we make it -1. And so -1 means move to the left. Dx, or a change in x, is going to be negative. So we're going to move to the left. However, we'll then say, wait a minute, let's ask another question. Else if, here's our question, key is down 68. That is the D key. So is the D key being held down, or is the right arrow key being held down? If that answer is yes, then we are going to make dx +1. We're going to add 1 to it, which means moved in the positive x direction. So dx is 0 if we don't want to move at all. It's -1 if we want to move left, and it's +1 if we want to move right. What we need to now do is do something similar for the vertical direction, and we are going to support up and down keys and WS keys. So let's ask our question, else if, and then parentheses. Inside of the parentheses is where our question is going to go. So we're going to ask a question, and if that question is yes or true, we're going to not target dx, we're going to target dy. And we're going to target dy, and we're going to make it -=1. We'll subtract 1 from it. Now, This is where it gets a little confusing. Right here at the top of our screen is 0 for our y coordinate, and then y gets bigger and bigger and bigger and bigger and bigger and bigger until we get all the way down here to our height. So subtracting 1 actually moves us closer to 0. It puts us going up. The left-hand side in the x direction is 0, and then as we add it, we go bigger and bigger and bigger all the way to the width of our screen. So here, we're going to ask a question. Hey, if we want to go up, we're going to make dy -1. So how do we know we want to go up? Well, we're going to ask key is down, and we'll put the key code for W, which is 87. Or 2 vertical bars, we're going to say key is down, and we'll put up arrow, because those keys don't have an actual key code, I don't think, or they have shorthands that we can use, so like constant names, left arrow, right arrow, up arrow, and then down arrow. So now let's do one more. We'll say else if key is down. This time we're going to go down the screen. So we're going to use the S key, which has a key code of 83, or key is down, and then we'll use the down arrow. And then what do we want to do if we press that? Well, we're going to take dy, and instead of going -1, we're going to add 1 to it. So we'll make it plus equals 1. All right, let's refresh the game. Let's see. Can we move it all? So left and right is broken. Ooh, down I can move. And I can go up. So that's kind of good. I can go up and down. Hey, that's awesome. Wait, get back here. Where'd he go? Where'd my little fried egg go? Oh, my fried egg can go off the screen, so that's not good. And it's also not good that left and right are not working, but up and down certainly are. Okay, if I press left and right, I just stop moving. So something is not yet mapped up correctly with this horizontal motion. But I think we solved the vertical motion correctly. So mission 4 is done. Now, before we go to mission 5, we've got a really important line right here. Inside of this function, get input direction. Okay, inside of this function, we have these variables, dx and dy. These variables only live inside of this function. And so the last line of this function says return, and then we bundle them up into an object. Note the curly brackets, just like our player object, with dx and dy. When you return something, it will go, this value that I've got highlighted, will go back to wherever this particular function was called. So if I scroll up just a little bit, I have a function called update player, and we are calling get input direction. So when that function gets called, we determine what are the dx and dy values. How should we change the player in the horizontal and vertical direction? Is it 0, -1, or +1? We bundle them up into an object, and they get returned right here, and we store it in a variable called move direction. So move direction now has 2 properties. It has a dx and it has a dy property. And so you can see here, we're sort of accessing. If those values are not equal to 0, meaning we want to move, we are now targeting our player's dx property and setting it equal to move direction dx. We're targeting our player's dy property and setting it equal to move direction.dy. So now my player knows what direction it should be moving in. All right, so that's huge, because then in mission number 5, which is where we find ourselves right now, we want to update our player's position. It says update the player's next grid column. Use the current column and the horizontal direction value. So if you look, our vertical movement is working great, and we know what row we want to go into next. It says player.row plus player.dy. So take the row the player is currently in and then add to it their dy value, the direction they want to move in. And remember, dy is either going to be +1, -1, or 0. So right now, it's 0. And if I press the up key, we're going to make it -1. So we're going to add -1, and it's going to go up 1 spot, and then 1 spot, and 1 spot, and it keeps going. Right now, it's 0, but if I press the down key, dy is going to be +1, and it starts to move down the screen. So we need to do the exact same thing here for our columns, which is the horizontal direction. Our columns, it just snaps to 7. Oh, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. Is that why? Oh, 0. Silly me. Remember our first conversation? We start counting at 0 with digits. So this is 0, 1, 2, 3, 4, 5, 6, 7. Look at that. That's why it keeps going right there. When we call the player's update function, we are hard coding the next column that we go to column number 7. We do not want that. We want to look at the player's current column, and we will add to it the player's dx property. So that's either going to be +1 if they want to move to the right, -1 if they want to move to the left, or 0 if they don't want to move at all. Now, before we test this, where are we calling update player? How do we know we're calling this function? You can stay here, but I'm going to jump. I'm going to jump to our default P5 game functions. Remember, setup gets called once at the start of every game. There it is. It just got called. And draw gets called every single frame of the game. So if we're running at 60 FPS, this is 60 times a second. We're going to update our player and draw our scene. So update player is getting called 60 times a second, or every single frame. So every single frame, we are going to now move the player. Let's test it out. I have up movement, down movement, left movement. Ooh, that feels good. And right movement. This is perfect. Now, I don't know about you guys. This player is extremely slow. It is super, super boring. So we got to change that player speed. And that's going to bring us to mission 6. Mission 6 is going to have us increase the player speed. Player speed, that seems like a knob or a dial that we should be able to turn or adjust to change how our game plays or feels. So that means it is inside of our student edit zone. We don't have to worry about really breaking anything here by changing the player speed. It's going to be a constant because once we define it, it's not going to change over the life of our game. It's currently set to 6. Let's have some fun. Let's make it 80. What is going to happen? I don't even know. Is our game even going to work? Let's see. Whoa, way too fast. I'm zooming across the screen. It works, but it does not work well. We got to slow ourselves down. I'm going to set it to 14. I think 14 is going to be a much better value. All right, I like that speed. So this is really good for me. But there's just, wait, get back here. I don't like that he goes off the screen. I got to keep him on the screen. You see how he can go below the height, he can go below 0, he can go past the width of the screen. We need to somehow keep our little fried egg player in the game window. And that is what mission number 7 has us do. It finds us in update player. All right, it finds us in update player. We know update player runs every single frame of the game. And if you look right here, we ask a question. It says, if the next column that we are trying to go to, we're going to move our player. If that next column is less than 0, meaning here's our 0 column, we start counting at 0, it means it's over here, we're off the screen. Or if the next column is greater than that variable that we created, grid columns, that's 40. So if the next column is going to put us all the way over here, or the next row is less than 0, which means we're trying to go up. So here's row 0. The next row would be less than 0. It would be up here. Or the next row is greater than or equal to our number of grid rows, which is 28. We're trying to go off the bottom of our screen. We don't want to allow it. So we're going to implement a world boundary rule here. Anytime our player goes off the screen, we are going to reset the player. So to reset the player, I think we looked at a function for this, right? We had reset player. We're just going to call that function. Let's go look at the reset player function. When we reset the player, we are going to put them back in the middle of the game board. Their column and row are going to be in the middle, and we're going to stop their motion. Dx is going to set to 0. Dy is going to get set to 0. But there's one last thing we should do here probably, because if we reset the player, we don't want to run any other code that might exist, like down here. So the way we stop running any code in this function, we type the word return, and it will return us out of the function. And if you saw return where we return some information, this time we are just going to return without giving anything back. No information is leaving. We are just going to exit this function. So let's test mission number 7. Now, if I leave, boom, I'm right back. So that makes leaving the gameplay area is going to have negative consequences. Oh, right back to the beginning. Oh, right back to the beginning. And oh, right back to the beginning. We are well on our way. There's just one last mission because we said we were going to have 8 missions here to take that terrible, terrible first state of the game. I don't even remember what it looked like because we've done such a good job making our little fried egg player come to life here. We have one last mission to do. We said we were going to do 8 of them. Here is mission number 8. It is all about our game's HUD identity. We got to change the game title text to give our version of our game a custom name. The name of our game is Territory Rush. So it should say that. We should, that's marketing, man. We should have this say Territory Rush, not game name. Now, this section up here is what we would refer to as a HUD or heads-up display. It's where we can show information about our game. If you look, we have a draw HUD function, We have a draw player function and a draw background function. And these are all being called from within draw scene. You can stay here. I'm going to jump. I'm going to go look at our default P5 game functions. Setup, which runs once every single frame, and the draw function, which runs the setup function, which runs once at the start of our game, and our draw function, which runs every single frame. We update our player, and then we are calling draw scene. So this function is getting called over and over and over again every frame. Now, the first thing that we do is no stroke. This means I'm going to pick up an invisible marker so you don't see the outline of the shape that I am about to draw. Then we put some paint into our paint bucket with the fill command, because that shape that we drew, which had an invisible outline, we are going to paint it in. And we are painting it in with an RGB alpha string. 0 in the red, 0 in the green, 0 in the blue. That makes black with an alpha channel of 0.7, which means I'm going to be able to slightly see behind it. Then we draw a rectangle with the rect function. The rect function needs 4 pieces of information. It needs the x and y coordinate of the top left corner. So in our case, 0, 0. That is right here. Then it needs the width of the rectangle. R is the width of our canvas. This is the width of the canvas. And then the height of the rectangle. Ours is our constant variable HUD height, which is 60 pixels. So we start here, we go the width of our canvas, and we go down 60 pixels. That defines our HUD rectangle. Then it looks like we switch our paint color up. We put a new paint color in our paint bucket, our text color, which is sort of white. And then we are aligning our text in the horizontal direction left and in the vertical direction center. Then we set our text size. So this is like setting up to make some text. Let's change our text size. Let's make it 60. So now our text should be a lot bigger. Whoa, there it is, game name. Now, let's change our alignment. Right now, it is left aligned in the horizontal direction. That means in the string that you are displaying, see, there's a string. It's inside double quotes. The left side right here, which is our letter G, is going to be positioned horizontally at a 15 pixels. So this text function takes 3 pieces of information. The string you want to show, the X position, and the Y position. And the X position is set right now to be the left side of the string, so with the G. Now we could change that. Let's do center. So if I do the center, now it's going to be the center of the string, which is probably this space that's going to be at 15 pixels. So if you look, when I refresh the game, the space should be right here, and it should say space name. Space name! Look at that. Also, a terrible, terrible name for a game. Let's stop having fun here. Let's change the text size back to 18. Let's change the alignment back to left. And then let's officially change the name of our game to Territory Rush. And with that, I think we're done. Hey, that looks great. You want to move the text? Let's make it, you can do 100 pixels in and maybe 45 pixels down. We 100% can do that. 100 pixels in, 45 pixels down. Boom. That string has been changed. But I'm going to hit Control Z to undo those 2 changes because I like where that text is set. And with that, our game is now complete. Our gameplay world is well on its way. Our player can move across the screen. Territory Rush, while not yet taking a good form here, it's just kind of like a little fried egg moving across the screen. It is light years better than what we had prior, and I can begin to see the potential of this game. So I think this is a great place to start here. We built out our gameplay world. The color scheme is wonderful. Our player looks great. Our player moves perfect throughout our grid system that we have created. And anytime we go out of bounds, we set the player back to the beginning and stop them. So the gameplay here, that structure, is a good, solid loop. We're going to continue to build on this loop in the next video. So I can't wait to see you then.